Just in time with the official start of summer in Australia, we had some hot and sunny days. And with the sunny season starts the daily ritual of applying sunscreen. But how does sunscreen actually work? Is the fear of toxic ingredients justified? Should we avoid certain brands? And does it destroy the environment? Let's have a look and bust some myths about sunscreen. Hello and welcome back to my channel. Sunlight is not only nice but also vital for our survival. Too much UV radiation, however, does not only lead to sunburn and prematurely aging skin, but is also the only proven reason for skin cancer, or at least the only thing we can actively influence. Australia has one of the highest skin cancer rates in the whole world. Cancer Council Australia reports that about 2 in 3 Australians will be diagnosed with some form of skin cancer before the age of 70. Apart from clothing, wearing hats, or simply staying inside, sunscreen is a great protection from UV radiation. But how does it work? How sunscreen works? There are 2 types of active ingredients in sunscreen: UV absorbers and UV reflectors. Let's start with the latter. UV reflectors. UV reflectors are basically a form of physical protection. They are mostly made up of mineral nanoparticles that absorb and scatter, so reflect, UV radiation. The nanoparticles that are mainly used are titanium dioxide, a white pigment that finds use in wall paint, toothpaste or chewing gum, or zinc oxide, another white pigment that also finds use in paint or on the coatings of photo paper. UV absorbers. UV absorbers are a form of chemical UV protection and contain aromatic molecules. Aromatic molecules are substances that contain one or more of those rings. These rings enable aromatic chemicals to absorb UV radiation and convert it into very low levels of heat. This level is so low that most people don't actually notice it, although there is a small proportion of people that report that sunscreen makes them feel uncomfortably warm. Both UV reflectors and absorbers stirred up discussion about safety and toxicity. Let's have a look. Is sunscreen toxic? A recent study published in 2020 in the Journal of the American Medical Association got widespread media attention after it reported that these aromatic chemicals in UV absorbers can get into the bloodstream. This study was supposed to determine whether commonly used sunscreen compounds exceed the limits of 0.5 nanograms plasma concentration per milliliter of blood, which are the recently updated FDA guidelines. The researchers looked at the absorption of the 4 most common organic sunscreen ingredients: avobenzone, oxybenzone, octocrylene, and ecamciol. They monitored 24 healthy participants after applying 4 commonly used sunscreen formulations over 7 days. And they found that the levels of aromatic compounds in the blood quickly rose over the FDA guidelines regardless of the formulation, and that they stayed in the bloodstream for at least 2 days. But the conditions of this study were seriously extreme. Some 75% of body surface was covered in sunscreen, which was also reapplied every 2 hours under no conditions of removal or breaking down, like swimming or sweating, which would occur in our everyday life usage. It's basically simulating a worst case scenario. Now, does this mean those UV absorbers are toxic? No. First of all, going above the FDA guidance level does not indicate a risk. Second, Australia actually uses the European Union guidelines on product safety, which are much higher than the FDA guidelines. Third, there's a wide range of studies, on most of which the European Union actually base their decisions with regard to sunscreens, that show no toxic effect or potential harm to human health. The level of specific chemicals like, for example, avobenzone, after regularly applying sunscreen is around 1,000 times lower than the threshold level for potential harm to skin cells. Researchers also investigated a potential endocrine disruptor effect of aromatic molecules in sunscreen. You heard about this term already when learning about parabens in my first cosmetic video. They mimic the effect of the female sex hormone estrogen. And these researchers found that levels would need to be about 100 times higher than the absorbed amount during normal sunscreen use to have any effect. However, there is a small risk of skin sensitivity for UV absorbers. If this is the case, maybe rather use nanoparticle containing sunscreen. Concerns about nano sunscreens were first brought up in 2008 when a BlueScope Steel report stated that metal oxide nanoparticles were capable of bleaching painted surfaces on coated steel. Since then, many scientific studies have shown that nanoparticles in sunscreen don't readily penetrate the human skin. This landmark study showed that after a 5-day trial with sunscreen being applied twice daily, the zinc appearing in blood was only 1/1000th of the total zinc that we have naturally in our blood. This led to the European Union Scientific Committee on Consumer Safety declaring in 2012 that use of zinc oxide nanoparticles at concentrations of up to 25% as UV filter in sunscreen is safe for dermal application. However, nanoparticle-based UV reflector sunscreens should not be used in spray form, as this poses the risk of inhalation. And taking up nanoparticles through the lungs is a completely different story than applying them in lotions on your skin. Ultimately, using sunscreen reduces your risk of skin cancer considerably, and in my opinion, that outweighs the minimal risk that might come with those ingredients. In short, the science so far says it's most likely safe, and I suggest, particularly in Australia, that you rather use a sunscreen because skin cancer is coming for you. Okay. Now that we know that we can carefree use any sunscreen, how do we choose the right one? For that, we need to understand the SPF. How to choose the right sunscreen. The SPF. Sunscreen in general provides a screen, not a block. It's a bit like a fly screen. The air gets through, but the flies don't. Similarly, the sunscreen on your body will let through a small amount of UV onto your skin. The sunscreens you can commonly find in the supermarket or at the chemist are classified by the SPF. SPF stands for Sun Protection Factor. And what does that mean? It is an indication how much UV radiation gets through your sunscreen screen. The higher the number, the less UV radiation passes through. So an SPF of 30 only allows 1/30th or 3.3% of UV to reach your skin, while an SPF of 50 only lets 1/50th or 2% through. Let's look at this in a more applied way. Imagine your unprotected skin would take about 10 minutes in the Australian sun until it shows signs of burning. Looking at all the redheads and British people out there, usually this happens by turning red. This is called erythema. Now, you properly apply sunscreen and look at the time it takes until erythema shows up. With an SPF of 30, this takes exactly 30 times longer, so 300 minutes instead of 10. With an SPF of 50, exactly 50 times longer, so 500 minutes. And with exactly, I mean average. This is an idealistic scenario. The real world is, however, dependent on your skin type and their self-protection time. We differentiate between 6 skin types, although the transitions are very fluid. And even within the 6 main skin types, as well as in between them, the self-protection time can vary massively, from 10 minutes all the way up to 90 minutes. The SPF on your sunscreen bottle is therefore only an average value. And you should also keep in mind that an SPF of 30 and above is not really measurable in the lab anymore. But there's one more consideration about the choice of sunscreen. You might have heard mixed messages about its harm to the environment, particularly coral reefs. But is this true? Let's look at the science behind it. Are sunscreens destroying coral reefs? The environmental concerns about sunscreens harming coral reefs are about UV absorbers, so aromatic molecules in oceans, and are mainly centered around 2 studies. In the first one, published in 2008, researchers exposed small fragments of coral, so the branch tips, to high levels of benzophenone 3 and a few other chemicals. They let them incubate for a few days in plastic bags and discovered that the coral fragments in the bags quickly became diseased with viruses and bleached. From this, the researchers concluded that up to 10% of the world's reefs are threatened by sunscreen-induced bleaching. In the second and most widely cited study, researchers focused mainly on the responses of the day-old larvae of one coral species, as well as isolated coral cells. The larvae was placed in artificial seawater containing a range of concentrations of sunscreen chemicals and solvents to disperse them. They observed that after a few hours, the coral larvae became increasingly bleached with higher concentrations of oxybenzone. They also took some random samples at different locations and concluded overall that the use of oxybenzone in sunscreens threatens the resilience of coral reefs to climate change. Now, does this mean that all coral reefs are doomed from our use of chemical protective sunscreen? No. There are some flaws with these studies. First and foremost, these studies were done ex situ, so not with an actual living part of coral reef in the ocean. So the experimental setup is not really representative of real-life conditions. For example, the way that coral tissues were exposed to sunscreen does not mimic the dispersal and dilution of pollutants from human skin into reef waters in the ocean and onto corals growing in the wild. The experiments also used a far higher concentration of sunscreen chemicals that are actually measured on the reef. This recent review found that the concentrations of benzophenone 3 are usually only a few parts per trillion and barely detectable. In conclusion, there is actually no direct evidence that shows that coral bleaching from global warming is exacerbated by sunscreen chemicals. Similarly, there is no evidence that shows that recovery from thermal bleaching is impaired by sunscreen or that they cause bleaching themselves. Does this mean our coral reefs are under no threat of sunscreen pollutants? Not really. Considering the many stresses already faced by reefs, the best way is a precautionary approach. Most experiments to date also have been of a very short duration, up to a few days maximum. Whereas in real life, UV filters from sunscreen might be at a low concentration at first, but might accumulate in organisms or sediment and persist. Unfortunately, there is no real answer to this question yet, and a lot more research is needed to really protect coral reefs in our oceans. So, what did we learn from all this? Here are some sunscreen tips for you. Sunscreen tips. Number 1. Make sure you use enough sunscreen. About a teaspoon per limb, face, front and back of the body. Number 2. Apply at the right time, approximately 20 minutes before leaving the house, and reapply often enough, depending on where you are, every 30 minutes to every 2 hours. Number 3. Choose the right sunscreen. Go for a high SFP and for a broad spectrum protection, which filters the full damaging UV light spectrum. UVB rays are between 290 and 320 nanometers wavelength and are mostly responsible for sunburn and DNA damage on the outer skin layers. But UVA rays ranging from 320 to 400 nanometers can cause DNA damage in the deeper skin tissue and accelerate skin aging. The active ingredient really only plays a role when you have known allergies or skin sensitivities, or you really want to spray it on. Number 4. Use coral reef friendly sunscreen and other methods of UV protection, especially when snorkeling or diving in close proximity to them after freshly applying sunscreen all over your body. And number 5. Never rely on sunscreen alone, even with a high SPF, as your only method against the sun. Always think about the Aussie slip, slop, slap, seek and slide, seagull. So, slip on a shirt, slop on some sunscreen, slap on a hat, seek some shade, slide on your sunnies, and most of all, stay sciencey.